So hello everyone and welcome back. As you can see today I've got two drivers, speaker drivers, and what I'll be looking at is how to build an enclosure for these drivers and the essential requirements and what are the critical considerations without access to a woodworking workshop and that you can do yourself at home. So let's get started. So I had these speakers for many years, and recently I decided to upgrade my hi-fi system, and this is just a brief view of the new system. So I then took out the drivers from the old enclosures, and they've been lying around, so I decided why not put them into proper enclosures. And I went online to check how to go about building an enclosure, and there's hundreds of videos that explain and show you enclosures being built with proper woodworking equipment and large workshops and requiring expensive clamps and other things, whereas for me that's not an option. I want to get cut to size pieces and build the enclosures with the minimum tools and equipment that I have. So let's look at what is required. Okay, the first thing you start off when you're working on putting together a speaker is the diameter of the driver. And in our case, the drivers, the main subwoofer drivers, are 300 millimeters in diameter. So that is the driver diameter. After the driver diameter, you can work out the height, the width, and the depth. And you get these panels. Usually the front panel is just a full size, height by width. And there are various configurations that you can use for the side, top and bottom panels, and that is explained a bit more here. There's a version 1 where the two front and back are the same full size, and two top and bottom are full size, and two sides are height and depth minus twice the panel thickness. So you end up then with different types of joints on the side. So in version 4, because my figure here is version 4, if you have the front and bottom front full size and top and bottom are full size minus the panel thickness, you end up with joints along the side like that and one joint along the top. And other versions, you have an L-shaped joint on the side, square on the bottom, and each of these different versions have their own advantages and disadvantages. This is something that is not covered by, well, I have not found any coverage on this topic after extensive Google searching. So I thought it's important because the joints make a difference to the appearance of the speaker and also how you are able to put it together later on. And to visualize that, I have drawn it up all in Fusion 360, and you can see now I can blank off the top, and that's what it will look like. But you have a joint along the top there. Or if you blank off the bottom, you have a joint like that along the bottom. But the advantage of this configuration, where the bottom is the full size width, is that all the weight is supported through the side panels. Whereas another configuration where the bottom is just inside, the weight, you cannot put any weight on that centerpiece. So all these different variations have to be taken into consideration. So in this case, once you have it in here, you can change the parameters, and you can, if you have a 250 millimeter speaker, you change that and all the sizes will change accordingly, so it becomes smaller. So you can look at it and think about how everything will be put together, and it helps a lot in making the final decision. Now, let's see what the steps are in assembling it. To assemble it, you have to glue one panel to another, and for this particular configuration, the version 4 configuration, the top panel and the front panel would be in the first step, so it's easy to put them together because they are flush along the sides, and you don't need big clamps and all. You can put tiny little screws to hold that while the glue is getting set. Then step 2, this helps a lot in visualizing how you put it all together, is putting the bottom on, and the same thing, you screw it and these sides are flush, so it's easy to line it up, and you have a squaring jig to keep those two sides square. Then step 3, is you put on one side panel, and again this edge is square, so it's easy to push it all together and keep it in place, maybe even on the floor if you don't have a large table. And step 4 is putting the back. This is important because then the last piece becomes the other side, and that just pushes against that, and it can be kept on either on this side or on the other side. So you have to think about how you're going to glue the whole thing together. And let's see, we'll get the last one up. And that's the full speaker all glued together. So now, just to wrap this up, there are a few things to consider. First of all is the material for the panels, whether it's going to be particle board, plywood, MDF or Veneer MDF. Each of those have separate issues, and also the joints, whether you're going to have miter joints or butt joints. Now, if you choose a veneered particle board, you have these edges that need to be finished. So the edging will need to be done by putting a little strip of the same veneer. It's pasted along each of those edges, because otherwise that will be exposed wood. It won't look nice. But this won't be needed if you use a miter joint, which is a 45-degree angle. The other thing is you can draw up all the panels and put them on a layout so that you can see the direction of the grain of the sheets usually goes top to bottom along the length. So then you need to have all the panels cut the same way if you're using a veneered board. And then you can see whether the panels fit in one sheet of whatever material has been chosen. Either particle. And then the other advantage of veneered panels is that you don't have to waste time sanding and polishing and painting and sealing and all that. You just have to stain the wood and you get a nice wood finish. So anyway, that just about sums it up. I'll leave some links on useful sites that give you much more detail on all these points. So now, to sum up, we can create a drawing, and we got a parts list, and you have all your sizes, and you can send this off to get a quote, and then you know exactly how much the speaker is going to cost. And in my case, I sent this quote. And I was quoted $340. So I'm still deciding whether it's worth spending that money for spare speakers that I'll have to sell anyway. And I don't know whether I'll be able to sell them for that price. So you can see how helpful this whole process has been. There are lots of websites which go into all sorts of further details of speaker displacements and sound pressure levels and all sorts of things. If you want any, if there are any questions about them, just ask in the comments below, and I will tell you which sites have been helpful to me. So that's about it. I hope this has been helpful. If you like it, make sure you click like and subscribe to my channel. Thank you. Bye.